Thank you. Thank you very much for coming to this panel. And obviously, quantum is a challenging topic. It is the ultimate unconquered frontier for digital technologies. And on one hand, it excites a lot of buzz and expectations, but the road to get the actual advantage for our economy, for our societies, is long and can only be conquered if we work together. So the goal of today's panel is to highlight some of the current events and forces at play in Europe and globally in some aspects of quantum technologies, and to see how we can be more efficient together. So 2024 is the year when all members of European Union have declared their political will by signing European Declaration on Quantum Technologies, and I quote, with the ultimate aim of making Europe the quantum valley of the world, the leading region globally for quantum excellence and innovation. So, let me start with interrogating our panelists, and they represent different sectors of this developing field. Milja, if I may ask you, Finland bets big on quantum computing. Why, and what is the role of your company in that race?
Thank you so much. So even though IQM, the company that I represent, is rather new, we started in 2018. The science behind it for Finland is nothing new. So this is something that has been done since 1960s in the cold laboratory sciences at Aalto University. So we have a very good basic research in this area on which we have built upon. Why Finland is betting on this? Well, we have many good companies in the past in technical areas, and I think overall the comprehensive security aspect has been rather in the heart of how Finns view the industry. And what we at IQM do, we build critical infrastructure, we build the hardware. As you know, before we get the hardware right, we cannot do really anything with these computers. So that's why we are really building the basis on which quantum industry can then grow upon.
Okay, so if I want to buy a quantum computer, can I contact the sales offices of IQM? Is that a real thing, or this is just some future plans? What's on the table right now?
Exactly. So what we do is we build world-leading quantum computers for the well-being of humankind now and for the future, and emphasis on now, as we have already developed and delivered 6 computers. So if you're in a market for a quantum computer, we got you covered.
Oh. Okay, thank you. So we hear that the quantum computing devices are already in the market, and there are companies making that possible. There is a big question of the industry: when and what quantum advantage will we be able to deliver to our customers? My next question is addressed to Professor Ambainis, who participated in drafting the Strategic Research and Industry Agenda for European Quantum Policy, on looking at the cutting edge scientifically. What's the state of play of quantum computing, and what are the bottlenecks where resources need to be allocated?
And I think there are 2 very important challenges which we both, and we try to address them both when writing the strategic research and industry agenda. So one is developing quantum devices, and another one is developing applications for them. So similarly to classical computers, you can think of quantum computers as a technology stack, which starts with basic hardware, and then on top of this hardware you build software and applications, and then there are algorithms which are in the heart of this application. So the 2 most challenging layers of this quantum stack are quantum devices on one hand and quantum algorithms on the other hand. And if one has those 2 and one is in a pretty good shape. And so devices, it's understandable that for quantum advantage we need quantum devices, and algorithms, we need algorithms that we can run on these devices. It makes a difference how much resources does quantum algorithm needs. Building quantum devices is hard, so for them to be useful, we must optimize our quantum algorithms as much as we can, so that they can be run on the devices that we have now, or devices that we will have in 5 years. And developing better quantum algorithms that need less resources is a challenge that my research group at the University of Latvia is trying to address.
Thank you. Thank you, Andres. So coming back to the, the software side, obviously that's the domain of theory, but the academic research in quantum technologies continues also on the physics side. And I'm addressing my next question to my colleague, Gerbon Menard, from Paris ENS Physics Lab. I know that your lab is also part of the French National Quantum Plan. And you, as a representative of academia, how do you see the role of basic science in implementing the quantum strategies? Because the opinion often heard is that, well, science has done its job. All that remains is now engineering, scaling up, developing use cases. Kind of, maybe we don't need any more investment in quantum science.
Well, I think one of the biggest issue with quantum is actually we don't know what will be the technology that will be used in the future that will give you an actual advantage compared to classical computers. And also, like, we need to remind ourselves that quantum is quite recent. Like, it only has about 100 years. So it also builds itself on top of the classical computing, which also itself is not that old when you think about it. So what we're trying to do is to explore and to try to figure out how can we use this quantum advantage, like how can we take advantage of the way particles exist at the scale that they're useful for quantum. Like, okay, an electron is not a particle, it's not a wave, it's something in between in quantum, but that's something that only works if you are low temperature, if your computer is well protected from any outside perturbation, so what we call, for instance, decoherence in the domain of quantum computing. And that's one of the main issues, like the scalability and the accumulation of error when you're working with qubits is a real issue, because then you need more qubits to correct the errors than to actually make the calculation. So what we're trying to do in our team is to study some particles, what we call anyons, which are theorized to be like, so they are topological particles in the sense that they actually have some protection against fluctuation, perturbation of outside perturbation. And so that's one way of doing things, but also part of the strategy that Microsoft took a few years ago, for instance, for the investment that was made in Copenhagen and Delft, for instance. But there's a lot of different ways of doing things. Like, so we talked about that yesterday. So to give the example of France, we have a lot of quantum startups, and a lot of them use different techniques. So you have cold atoms, based computation, you have solid state qubits, you have quantum dots, you have like cat qubit states and stuff like that, fluxonium, and so the technology, there's a lot of possibilities, a lot of opportunities, but we don't really know what will be the actual solution. And then in the meantime, as researcher, we try to figure out, okay, what are the limitations, what's causing the limitation, and how can we try to overcome them?
Okay, so I hear that there is still a race also in terms of the hardware platforms, which would be helpful to realize the advantage, and the long-term perspective is what's being kept current on the academic side. Milja, your company is building a particular on a particular platform, where Finland has historic strengths, the low temperature physics and the superconducting physics. How do you see European efforts on a global scale? Maybe some skeptics would tell you, well, this is too late for Europe to be in the race, and maybe we should give up the hardware to some other players and focus on smaller things. What's the ambition?
Well, if we are looking at pure numbers, Europe is not behind. We have one of the highest numbers of talent when it comes to PhDs and master's degrees in quantum. We also produce most patents globally. And then again, if we're looking at just purely the revenue of the global players, IQM and Europe on a wider basis is very competitive. Well, when it comes to hardware, of course, the game is still open. We don't know which modality will win. But then again, if we're looking at on a more wider scale when it comes to tech hardware, especially in AI and quantum, we have seen how there has been a shift first from hardware to software. We have let the hardware production go outside of EU, outside the West. And now, when the tech has developed, we have moved back and tried to get the hardware production back to Europe. As quantum is still developing, I don't think we can risk losing this battle. And then again, I understand that as it's still a guessing game, what quantum will actually be in the future, it's good to be a little bit critical. But then again, these investments in hardware will produce high-paying jobs, get high talent to European Union, to Finland, get foreign investments, and also tax incomes for the states. So it's never a wasted investment. And for example, the case of Nokia in Finland, even though it maybe didn't produce exactly what we expected, now Finland is one of the leaders in advanced networks because of Nokia and the basic research that we have done. So you don't really know what the future will tell us, but then again, it's never a waste.
Thank you. Thank you for your perspective. Obviously, developing technologies and being competitive in the world, Europe has to act together, but that's probably easier said than done. And the challenging task of coordinating national efforts in the implementation of quantum declaration falls onto the shoulders of European Commission. Now with the new European Parliament and new European Commission, I presume your office, Katie, is pretty busy with trying to make more concrete and real the action dimensions mentioned in the quantum declaration. Could you offer us a perspective on how to coordinate that efforts, that they are complementary, not how to make the interference constructive, to use the physicist term? Katie, please.
Of course. I mean, as perhaps I should start by saying, as you know, that the new commission isn't quite in place yet. So we have to be a little bit careful with what we say, because we frankly, we don't know what the whether there'll be new policy initiatives. But perhaps I can start by putting the declaration in its wider context. Europe's been funding quantum for the last 25 years, quantum research. In 2018, we founded the Quantum Flagship, which was the 1 billion euro 10-year initiative to consolidate, to build on our excellent tradition of research, and to start funneling that research towards commercialization and industrialization. So Europe has been, for the last 5 or 6 years, quantum has certainly moved up the European agenda. In strategic terms, last summer the Commission published its economic security strategy, which is a set of ideas for how to navigate the rather challenging times in which we live and we will continue to live. And quantum was cited as a strategic area where we will need to sort of see, work out what our strategy is, who we collaborate with, what areas we will focus on. And quantum was specifically named in the follow-up recommendation on critical technologies. So again, quantum is high on the agenda in Brussels in strategic terms. Also in economic terms, as you know, Mario Draghi published his report on European competitiveness a couple of months ago, and this singles out quantum again as something that could be transformative to Europe's economy and society, and will be fundamental to competitiveness in clearly what is a highly competitive international environment. So this is just to sort of emphasise that we in Brussels, policymakers are thinking about quantum a lot, are talking about quantum, and this was one reason why we were very happy with the launch of the Quantum Declaration, which you mentioned. This is, as you say, this is a commitment from all member states to work together and to become, for Europe to become the quantum valley of the world. And the declaration sets out a number of areas for future action, more consolidation of research, more joint investments in quantum infrastructures, which is already happening with computers, for example, also EuroQCI for quantum communication. Also, other efforts, it talks about let's get more private funding. I guess we might talk about that in a minute, but this is, you know, areas where we need to address our relative weaknesses. But underlying the declaration is, as you mentioned, it's about coordination, alignment, working together. We're very happy that many member states like France have ambitious national strategies with significant amounts of funding behind them. Europe is very strong globally when it comes to public funding. We are ahead of all regions in that, except possibly China, and we don't quite know what the story is there. So you know, there's a lot of potential and promise, but as I say, the challenge now, or one of the challenges, the underlying challenge is to align and to coordinate and to talk to each other. The declaration comes with the creation of various working groups, expert groups, bringing together member states in Brussels, but it's also important that we keep talking at events like this one, so that for member states can collaborate, can form connections, and can see, you know, how they can work together to move forward.
Thank you, Katie, for emphasizing this. And speaking of collaborations on partnerships, and that's the question to all members of the panel, which types of partnerships nationally and especially cross-border have helped build your momentum and put where you are, and which you would suggest to be more of, or what new types of partnerships would be helpful? I don't know who's be happy to start. Maybe you, Andres. I know you are one of the implementers of the European funding in Latvia, and the quantum computing research center that you have built has been funded substantially from collaborative projects. Maybe you could elaborate on that dimension, how that worked so far.
Well, so our success has been largely built on us collaborating with other leading European research groups in quantum software. So we have had a long-standing collaboration with quantum software research centers in Amsterdam and Paris. I have been working together with people there as researchers for about 25 years. We signed a formal memorandum of understanding about 8 years ago, and the Latvian Ministry of Science and Education gave us some money for collaboration to support this collaboration. And this collaborative network is on what I have been building. We have been learning from researchers from Amsterdam and Paris coming as guest lecturers. We have been writing a lot of research projects together with them. In 2010s, we in Latvia we coordinated 2 European research networks that involved all the top European research institutions on quantum software, famous institutions and famous scientists. And the core of this project was this triangle between Riga, Amsterdam and Paris. And now we are expanding this triangle by creating a European Quantum Software Institute, which would be a virtual collaboration of 6 groups. So we are expanding this core of 3 to 6, and we are trying to build a European structure that would lead European research in quantum software.
Thank you. Thank you. What other types of collaboration? I think looking at Milja's kind of representing the industry in your remarks, you've already mentioned that the company obviously leverages the pool of talent that universities have to prepare, and that's one obvious input and connection dimension. But how do you see the role of academic research and other non-private players? Could you give us some examples or some calls for improving things?
Yes, well, first of all, IQM is a very global company, so we are almost 300 people, out of which almost half are PhDs. We have almost 50 nationalities, so we need to collaborate globally to get the best talent. We also need to collaborate with the universities to get the brightest minds into the company. Then again, on European level, collaboration happens, well, especially through EuroHPC, which is a EU-wide project to get these quantum computers into the supercomputing centers. So there are many levels in which we collaborate. Then on Finnish level, especially, well, I'm in charge of the government relations, so I try to explain quantum to policymakers and politics to our quantum physicists and decision makers within the company. And in this context, we also collaborate quite widely, mostly on national basis, so with our RTOs, with universities, with different industry players, because usually the needs and worries are rather similar when it comes to quantum. For example, regulation, financing, getting the best talent. So it doesn't make sense to go there alone and try to be the best in the industry if everyone else is trying to do the same. So we like to change views, discuss, and then combine our messages so that we are united. And this has worked rather well. And now that Finland is writing its national quantum strategy, it's done also on a wider level between the government, private actors, as well as the academic actors.
Thank you. So I do hear the added value of collaboration and having an alignment between different stakeholders, because it's not pure scientific talent that is necessary, it's the whole chain, also the dreaded valley of death for the technology before the market can actually start seeing the return on investment. There is this collaborative aspect, but also obviously that creates some competition, and the hope is that the competition can be steered to be healthy. Recalling our yesterday's discussion at the co-creation event, Gerbo, you mentioned Paris as a very kind of ground zero for quantum in France. I have some guesses why, but in the environment of competitive academic labs and the startups now giving very generous offers to the graduates of your PhD programs, don't you feel that steam is being taken out of the academic engine, or how does it feel in that environment?
So, to be fair, it's not only Paris, there's also big development in Grenoble, so in the French Alps. So there's in the field of quantum, there's the big two places when you can do that. But I just want to mention something, is that because we're doing basic science, there's a big emphasis put on openness of science, especially at the level of CNRS, so, and like universities globally. We have a push so that all the publications that we write are openly published online. So that's this free access for science, which I think, as academics, I'm not talking at all about then development, about industry and stuff like that, but for us, it's very important that we're able to freely communicate with our colleagues, wherever they're from, like being from the US, from China, from other countries all over the world. And then the way we create collaboration is by discussing, like, first of all, we are human beings, right? So it's so of course you're going to have feuds between, like historical feuds between research teams that can happen, like pettiness is also part of human condition. But in the end, it's really, for instance, conferences when you be able to hear what people are working on, which will spark ideas about, okay, that relates to what I'm doing. Maybe I can try to adapt that in a different setup. Then we can start communicating with people. That's really part of the project in which we're part of together. So, but the Quantera project, which is European on the scale, but then funded like locally and on the countryside. And so we are part of the German, Latvian, French consortium, but in the meantime, we also have different projects within France or just ourselves. But yeah, so being able to talk to people openly, I think for us is the best way to bring ideas out on the table and try to actually figure out new directions and what could be done.
Of course. Thank you so much for your perspective. I'm obviously biased. You've made a very nice advertisement for academia, so they're the types of people who will always be driven by acquiring new knowledge. But there is also the type of people who wants to bring the maximal benefit to society from that knowledge and that entrepreneurial skill. So I hear from you that, well, we should meet in person, we should talk, and this probably where the collaborations and the actual proposals for policy can grow out of. There is the dimension going further up the scale of technological readiness, which I gather is very crucial for Europe. That's the protection of the intellectual property and making sure that at the critical stage of the pipeline, when the idea was spun off from academia, grown in the early stages of investment, and then it's ripe for scaling up and actually conquering its niche globally, what is being done and what are the challenges for preventing this being snapped by other global players, and maybe here Katie and Milia have some perspective on IP protection and the support for the added value to stay and grow in Europe.
Mm-hmm. Sure. I mean, as you said, this is a challenge, and it's a challenge partly because, as I say, it's in the Commission's economic security strategy. It talks about partnering, but also protecting. So I think when any consideration of this issue has to take into account the fact that there are, of course, always advantages of partnering, particularly with countries outside of Europe, but there are also, there can be disadvantages. It's something perhaps in the past Europe has done, could be said to have done too much of, and then indeed there has been a bit of a brain drain. Perhaps we lost IP, lost ideas, lost people, which is unfortunate. When in terms of our research calls, as you may know, they are, some of them are open to the whole world. Some of them, the more high TRLs, are less open, and this is part of an ongoing process. It's not a fixed position, but it is also a strategic decision that the Commission has taken to make sure that these very important ideas go to Europe first. To take a slightly different perspective, I think one challenge that Europe has faced is, as I mentioned earlier, a lack of private funding, and both from industry, big industrial companies not in quantum, but also in terms of venture capital, the kind of the major injections of cash that the startups need to scale up. So perhaps I could just say something that we're doing concretely. It's something I mentioned in our discussion yesterday. The European Innovation Council, which exists in broad terms to identify Europe's most promising startups and to fund them. A couple of days ago, it announced its work programme for next year, and this includes something called the STEP, the Strategic Technologies in Europe Platform Scale-Up Instrument. And this will offer a total, next year alone, of 300 million euros to promising startups in strategic areas, including quantum. Quantum is specifically named in this programme. So the idea is not just to give them this funding, but for this funding to unlock even bigger investments from private investment funds. So that is something that is, will be happening in the next few months. Looking ahead a little bit further, it looks under the next Commission, well, like I said, we don't know this for certain yet, the next Commission is not in place, but it looks like the next Commission will want to move forward to completing the European Capital Markets Union. And again, one of the drivers behind this intention is that it would unlock, it would enable the creation, the enlargement of Europe-wide investment funds and would create a pool of capital for this kind of strategic scale-up investment that our companies need.
Thank you. That's a very important dimension to keep in mind. Actually, the reminder for all of us that the world has qualitatively changed, and that the economic security is a two-sided coin, with fostering openness and collaboration on one hand, and then being very aware of the need for defense and security. And this big idea was also discussed here in Latvia few days ago at the Forum for Economic Competitiveness on the auspices of the Latvian presidency. And one of the theses which was heard on the political discussions, it is an ages-old, of course, tension between business looking for market opportunities for profit and science looking for what is there to discover, right? And having an ecosystem when both sides thrive and maximize the added value, that's a common challenge. But one particular simplification or stereotype, which I find sometimes misleads in this discussion, is the simplification that science is either applied, then it's clear, it promises some technology, so you better hurry up, and we should steer that towards commercialization, startups, and eventual market value. And then there is basic science, and the moment you say basic science, oh, it's curiosity-driven, and then it's just pure curiosity. It seems to be disconnected, and then how is my curiosity better than your curiosity? So having curious and accomplished scientists on this panel, what is your answer to society's demands? What is the role of basic science, and why it's still important in the quantum technologies domain? I think, Andres, do you have a point on that? Why keep doing science? Science has been done. Now we should just get the fruits, you know?
Well, I think there is a range of things in between completely fundamental research and basic research. You can call these things applied research with 10 or 20-year time horizon, or practice-driven fundamental research. You can classify them in whatever way you want, but a lot of science is driven by some practical need, which then turns into fundamental science, and there is this cycle. And when I was a PhD student in the United States, I saw this cycle very well. There were people working in the industry research labs. They would talk to people developing products. They would come up with some idea on what would be important in 10 or 20 years down the road. And then based on that, they would build science. And then 10 or 20 years later, these things would turn into technologies. And I have seen this with methods for error correction in conventional computers. I have seen this with methods for ensuring privacy, but people working together with practitioners come up with inspiration, then they come up with something purely theoretical, and then 20 years later I hear about Apple putting this in their product. And this is something that we need to foster. And the question is, how do we build an ecosystem in which these things happen naturally? Like in Silicon Valley, they happen naturally because there is such a concentration of smart people from different backgrounds. So we somehow have to make this happen here in much smaller country with much smaller community. But then our advantage is that in Latvia everyone knows everyone, so it's easy to connect with the best people in another area.
Thank you very much. So What I'm also hearing in your perspective is that what science can give is the longer-term perspective and planting the seeds for future prosperity. Maybe coming back to the status of quantum technologies, where do you see our near-term applications and the more mature sides of quantum technologies? Well, it depends on the sector you're coming from, and where it's still a potential for big disruption. Is it that the computing has already on the converging side, or there also could be surprises? How would you just judge the scene on risk to disruption scale?
Would you?
My question sort of
To whom is this question? To me?
Well, if you to any of you, but if you can offer your perspective, that'd be.
Yeah, I think computing is something where we still have a few orders of magnitude gap between what we want to do and what we can do. So there is a lot of work that we need to do on both hardware side and software side, and I think there is a clear potential for modeling physics and chemistry and doing other things and processing data, doing machine learning, and typically algorithms about which we are sure require resources which are a few magnitudes above today's quantum computers, and things that we can run on today's quantum computers are things about which we are not quite sure. So, and I'm sure IQM is working on bringing the capacities of quantum computers a few orders of magnitude up, and our center and our partners, we are working on bringing the requirements of quantum algorithms a few orders down. So I think that in a few years these capacities will meet.
Everyone is talking about a time in which we have useful applications, 5 to 10 years, who knows? But I think important note is that the market already exists. We are already selling quantum computers. They are already being used by customers. It's estimated that the market right now is worth around $848 million US, and in 2040 it's around $106 billion US. So it's doubling each year. This is numbers by McKinsey. So the market already exists. What we can do with the computers right now is basic research, learning how to do quantum, developing the talent pool for tomorrow. And this is why, for example, we at IQM offer the computers and sell them to universities, research institutions, so that they can train the future talents for this growing industry. But of course, when is a very, very good question.
Surely, right? So, but yeah, to be ready for a disruptive advantage, you need to start working on that before it has become reality. Thank you for this perspective. Maybe I would like to kind of wrap up our discussion, also to have some time to get questions from the audience. I'll ask each of you what would be a message to the audience and one barrier to remove, or one wish, if only there could be more things like this that would help your mission, that will help the ecosystem to prosper. What is that one thing that you wish for, even if it's unrealistic, or maybe it is? So yeah, in any order, if you feel up to.
Okay, maybe you should just go like this. So,
okay, yeah, go ahead. Exactly. Yeah.
Once again, I'm going to go from the academic's perspective, and like for us, the most important thing is freedom of being able to pursue a research subject. Like, of course, you have example in history when people have been pushed and then actually gave some great results. I can, for instance, talk about like the development of nuclear power, this kind of things. Like it's been highly pushed by the industry, but also before that comes from push from the military to build a bomb in Los Alamos. And before that, actually, it's just people like Marie Curie just breaking pieces of rocks in the backyard of ESPCI to be able to extract some radium to actually study, or Röntgen to actually ask his wife to put the hand to make a radio of it. So it's more or less always starts with curiosity, and people actually be able to follow things that they don't understand. And for us, that's something which is very important. Also, I would like to add that scientists have, I think, from what I see and the discussion I can have with my colleagues, are very aware of the world in which we are living. So especially when it comes to global climate change and all these kind of things, like we also need to ask ourselves questions, okay, what do the research we're doing, what will be the consequences? Like for instance, so we're talking about reducing the need for more qubits in order to find more efficient, because a quantum computer is not going to be like a laptop that you have today, right? It's going to be something that works at low temperature, which requires a lot of energy. It's not something you'll have with you just to make a PowerPoint presentation, right? That wouldn't make any sense. But some very specific applications, at least in the middle future, like not the nearest or maybe the longest. We'll find some ways to get things even better. But like it's something we need to think about, and as academics to have the freedom to think about it without having to absolutely every time trying to figure out straight from the start potential applications. So I know that's not the right conference maybe to talk about that. Like it's really technology oriented, and that's not really the background I'm coming from. But
right. Well, this is telling, right? That you feel scientists should not feel bad by being who they are, right? And being the best what they're doing, right? Thank you. Yeah, Amelia.
Maybe I want to leave you with the idea that Europe is truly very competitive in this area. The question shouldn't be about how to stay in the race, but how to lead. And I see that one way of cementing this industry in the European Union is by building this critical infrastructure, making sure that we have the capabilities of, for example, producing our own quantum chips, quantum hardware, because with that infrastructure, there will be talent building around it, usually these ecosystems built around the infrastructure. And also, this is an important note, because when we're talking about, for example, ethics and standards of quantum computing, we are already seeing, for example, with AI, that the actors who control the hardware, who control the infrastructure, usually also have a key role to play when it comes to partnerships, alliances, and how the industry develops. And this is why we need to stay in the race and keep the infrastructure here.
Thank you. Katie.
Well, I could say more collaboration, of course, but I mean, that goes without saying, and it is happening already. Perhaps one point I would make is come back to what I said earlier about private funding, particularly from industry. I mean, we know that quantum has the potential to be transformative in many different sectors, also transport, energy, tackling climate change, health, many potential uses, probably some we haven't even imagined yet. But what perhaps is a block to, so there's a lot of potential there, but compared with, say, the United States, European industry in other areas is proving quite slow to invest in quantum and to sort of unlock the levels of funding that will allow us to continue to be competitive globally. Of course, it's all very well to say industry should invest more. Of course, we, the quantum community, need to make a case for quantum. And as we discussed yesterday, there are different ways of doing that. One way is indeed to look to the future, to promise these, the amazing things that, should be able to happen in 5, 10 or more years. Another way is to focus on the here and now, perhaps the incremental changes, the incremental improvements that are, that quantum could bring about that are possible now or will soon be possible. So, as I say, I realise it's not persuading industry to invest, just like persuading national policymakers to take quantum seriously. It's not an easy argument, or it's a complex and multifaceted argument, but I think this is something that the quantum community needs to focus on, as I say, to ensure that level of competitivity.
Thank you. Thank you very much. Andres.
Yeah, well, my message would be that we often overestimate what the technological progress in short term, but we underestimate of how much technology will get better in the longer term. And this is basically the nature of the whole technology hype cycle in any field, whether it's AI in quantum. You often hear this will change things in 1 or 2 years, and that never comes true. But in the long term, the change is big, and that's how it will be with quantum as well.
Thank you very much. So on this note, I want to thank our panelists sincerely. They all deserve your round of applause. Yeah, the panel is open for questions.
Yes, we have about 3 minutes. A lot of people here in the room, exciting topics. Please, let's use this opportunity. We do have a microphone somewhere here. There is a question on that side in the last row. Good morning, what's your name and what's your question?
Good morning, I'm Stefan from CERN. I got a very simple question. Europe has a tradition in having lots and lots of bright ideas, and then we are slipping those ideas away. Electric cars are not built in Europe, batteries are not built in Europe, wind farms are not built in Europe anymore. All the innovation done in Europe is slipping away to other parts of the world. So how do you think that will not happen now with all the research we're doing in quantum in Europe? And in 10 years we're sitting here at the 11G territory, and then we're just lamenting about the fact that all those computers are sitting in Silicon Valley.
Okay, that's a challenging question. Do you address it to some of us in particular?
The Commission, because we're lacking visions there, and the visions bring us to keep this in our continent.
Mm-hmm.
Thank you. Yep, fair question.
I mean, as I mentioned earlier, this is something we're aware of. We're aware that we need to be strategic. We're aware we need to be careful in our partnerships. We're aware that we need to incentivize the best companies to stay in Europe, offer them the funding and the support and the talent that they need to do this. We're aware of the problem, but at the same time, perhaps I would like to add that this is not always a decision taken at European level. This is also, in some cases, a decision taken at national level. And so, we're very happy that European governments share our vision of quantum, its potential and its strategic nature, and I think we count on them too to bear that in mind when they are, making investment decisions or, in companies or engaging in strategic partnerships. So I think this is something we're definitely aware of at European level. We have a number of initiatives in place, but also it's a team effort, I think, too.
All right, thank you. We have 20 seconds. Quick question here. By the way, we have a QR code for feedback. Please do evaluate this discussion, give your remark, and scan this QR code. Quick question from you, sir. Hello.
Hello, Jans Karklinch. I'm ambassador at large in Latvian Foreign Ministry. So my question is about participation of quantum community in discussions about governance of quantum applications. In a digital world since 2003 at UN level, there is a debate about internet governance, digital governance. I am part of it, or has been part of it, and quantum has been mentioned marginally, occasionally, but quantum community representatives are not part of this global debate. Question is, do you have internally in the quantum community kind of discussion about governance issues, and whether you will be interested in joining a general, universal discussion about digital governance? Thank you.
Okay, thank you. Can we have a quick answer from somebody, please?
Yeah, I think these things are definitely discussed in quantum community. So the answer is yes. The challenge with quantum governance is that quantum is a technological tool that can be used in many areas. So essentially, every digital governance issue can turn into a quantum governance issue if quantum turns out to be useful in the particular area. So it makes the question of quantum governance very broad, and every new discovery of a new application can bring new aspects. But we are trying to think of this. There are parts of European strategic research and industry agenda that address that.
Excellent. Highly important questions raised, which, by the way, will be built upon in the next discussion, which will focus on quantum and defense in just 7 minutes' time. But right now, these people do deserve your applause. Thank you very much.